Suppose we have this number line. It starts from 0, and as we travel from the left or to the left, we've got -1, -2, -3, and so on. And we know that this is the x-axis, and to the right, it's all positive numbers, 1, 2, 3, and so on. So all of these numbers you can see here are just values of x, possible values of x. So if they say all real numbers, they are referring to these negative numbers, 0, and the natural numbers, which is also the counting numbers, 1, 2, 3. So all real numbers mean negative numbers, 0, and positive numbers. So now, why I am introducing this to you? I am introducing this to you because in this video, I will be explaining and letting you know what is a domain and how to find the domain of a function. Let's first define what's a domain. So as always, they define domain as the set of all possible values, like here, all the x's, that if you plug into your function, the given function you have, will give you defined result. So when you talk about defined result, it only tells us that there is a finite y value. So there is a point on the output. So let's say this is x and this is the function or the output. So input and then output. So if we say defined, let's say we have 5, and then as we go 5 here, we have 6 here. Whenever you have an x value which has also a y value corresponding to it, it is said to be defined. So that's what define is. On the other hand, so this is 5, 6. What is meant if they say undefined is if we have an input, so an input x, so this is f of x, then it has no corresponding y value. So what does it mean? So either that at this point on the x-axis, so or in the input, this axis, say this is 3 here, all the y values won't converge or won't hit a single point. So either the graph of the function will just go right here, or it will go downwards, or it will go like here and like that. So all these values come very, very close to this point, the undefined point to be exact, but won't really get to this number. So that's the idea of defined and undefined. And again, domain are all the all the inputs, possible inputs, that if you plug into your function will give you a defined result. Otherwise, if you plug in that number to your function and it gives you undefined result, then that's not part of the domain. Alright? To better see that, let's say we have here this function 1 over x minus 1. So that's y as a function of x, or f of x is equal to 1 over x minus 1. And again, we know that if a fraction, it doesn't, or it should not have a denominator of 0, right? Unless otherwise it will become undefined. So when the moment it becomes undefined, or 1 over 0, that function at that point that you plug into your x, it will not have a y value. So just like here, so what do you think is the number that could make 1 over x minus 1 undefined? Clearly it is at x equals 1, right? Because if you plug in x equals 1, you substitute 1 to the x, it will become 1 over, close in quantity, 1 minus 1, which is 1 over 0, right? And that will tell us that at point 1, just like here, this is 1 here, all the function will not hit, it's like here, it will never hit a y value. So just like here, if you see this one, so that's undefined on that point. So just like what I've said, if it's undefined on that point, it will never touch a y value. It will just go infinity, very, very close to that one. So this is the one here, this one. As you can see, as we go very, very bottom or downwards, no, it will not touch the one. So that's why it's undefined on that point. It has if you plug in this one here, it has, of course, it has an input, but never gives you an output. It never gives you a defined output. That's why it's undefined at that point. So let's say we plug in -2 2 to the function. So this is our x negative 2. So we'll get 1 over negative 2 minus 1, which is 1 over negative 3. So our y would be, of course, this function here. So in that sense, it is defined at that point. Alright? And then, if we plug in, this is very clear here. If we plug in 0 on this function, it will give us 1 over negative 1. And that's negative 1. So if we input 0, so this 0 here, we'll get an output negative 1. Therefore, at x equals 0, it is defined. And so, x equals 0 is part of our domain. So all these numbers, like 1, 2, 3, 0, 4, all those numbers, that if we plug into this specific example, this function, and it will not give us an undefined result or undefined y value, then that's part of our domain. Otherwise, just like what I've said, if we input x equals 1, and it will give us 1 over 0, then it is undefined, and thus, it's not part of our domain. So the only domain of this particular function here, just like this 1 over x minus 1, is just all real numbers except x equals 0. So am I clear now? Is it clear now? That's what basically a domain is. Now, there are a lot of ways to find the domain of a function depending on the given equation or a function. So here's how you find or solve the domain for any function you have, right? So let's say you have polynomials. So for polynomials, the domain of polynomials are all real numbers. There's no exceptions. You can plug in anything. So let's say 2x minus 7. So this is our function for polynomial. This is our first case, polynomial. So can you think of any number that if you plug in or input this function that will give us an undefined result? There's none, right? So the domain of this function is just all real numbers. Or in interval notation, it's just negative infinity to positive infinity. Because if this is our number line or the x-axis, we start from negative infinity, then let's say this 0 here, and then positive infinity. All the values here, the x's or the inputs, you can plug into this function. So that's the domain of a polynomial. Of course, that is true for another example, which is x squared plus 3x minus 5. So since that is a polynomial, so it will also have a domain of negative infinity to positive infinity. So there's no problem actually when it comes to polynomials. So all of the x's could be the domain of a polynomial. So the second one is, or the second case is, if we have rational function. So how do we find the domain of, for example, 5 over x minus 2? So let's say this is our function. How do we find the domain? Well, we know that the denominator cannot be equal to 0, right? Because otherwise, if we let that happen, the denominator becomes 0, then that's an undefined result. So since denominator cannot be equal to 0, we'll just have to set the denominator, whatever underneath is, just equate it not equal to 0. Since the symbol not equal to 0 because the denominator cannot be equal to 0. Just like that. And thus, for this example, x cannot be equal to 2. And so the domain of this function are all real numbers except or but x should not be equal to 2. So how do we write that in interval notation? It is said that if this is 2 here, so from negative infinity here, all numbers going to 2 are possible. So negative infinity. But since 2 is not included, because x cannot be equal to 2, we will just write 2 and then parenthesis. And then the union of from 2, so 2 is not included again, to positive infinity. Alright? So this is just the domain of this function. If it is a rational function, just like that. So case 1, if we have a polynomial, so all real numbers for polynomials. For rational function, just set the denominator not equal to 0 and solve for x. And then write or draw if possible so that you can see what is happening. Just like this one at 2. Since 2 is not included, so the domain is just this in interval notation. If it is inwards, you can just say all real numbers. So by means of real numbers, could be negative numbers, zero, and natural numbers or counting numbers. So that's it for rational function. Another example is if we have 3x minus 8. So f of x equals 3x minus 8 all over x squared minus 9x plus 20. So how do we get how do we solve for the domain of this function? Or what are all the values of x or the input here that won't give an undefined result? So again, if that's a fraction or rational function, just equate the denominator not equal to 0, since the denominator cannot be equal to 0. So with that, by this time, if you're not yet good or you haven't mastered yet the technique on factoring polynomials, you can click the I button above. I have playlist, I have a video separated for factoring. So, the factors of this, x squared minus 9x plus 20, if we think of two numbers that if we multiply together, we'll get 20, and if we add, we'll get negative 9, is negative 4 and negative 5. So the factors of this polynomial is just x minus 4 and x minus 5, which in terms we set not equal to 0. Then with that, we can say that x should not be equal to 4. Also, x should not be equal to 5. Alright? So the domain, therefore, if you draw a number line, so this is 0 here, and then 4, and then 5. So from negative infinity, so negative infinity here, all values except 4, so negative infinity, so that's parenthesis, and then interval notation, and then 4, so close parenthesis, union of from 4, so not including 4, so that's why it's parenthesis, 4 to 5, but not including 5, and then another union of from 5 to infinity. Alright? So this is the domain of this function. Or you can just say all real numbers, except it should not be equal to 4 and not be equal to 5. That's it. So from this region, so all real numbers, so from here, negative to positive 4, but not including 4. And then from 4 to 5, but not including 4 and 5. And then 5 to infinity here. So that's it for the second example under rational function here. And then the next example, if we have 2x minus 3. So go ahead, pause this video and try to solve this example. Hope you can find the domain of this. Done? So to solve this, again, just equate the denominator to 0, not equal to 0. Plus 4, that could become x squared not equal to 4. Negative 4. So if you think of it, is there any number that if you square it will give you negative numbers? I think there's none. Because even if the negative number, let's say negative 1, when you square that will give you a positive number, right? So there's no number that will give you negative 4. Even if you say negative 2 square, it will give you 4 and not negative 4. Therefore, the domain of this function are all real numbers. So it could be in anything. You plug in negative 4 here, you get a defined result. You plug in 0, you get a defined. You plug in positive 4, still. You plug in negative 4, still it's defined. So the domain are all real numbers. And in interval notation, that could be from negative infinity to positive infinity. Alright, so from here, the x-axis towards positive infinity when you travel. Our third case is if we have square root of a function. Say we have f of x. So this here, square root. I will just put square root in the cases. So actually this is case 3. Case 1 is polynomial. Case 2 rational function. Case 3 when we have square root of a function. So say we have f of x is equal to square root of x squared plus 3x minus 28. And before we continue, whenever you have index here that is even, so this is the process you'll do. I will show you later on. And if you have odd, That's all real numbers. You can plug in whatever you want. So let's say we have a cube root of x. Since this here is odd number, the index is odd number, so the domain is all real numbers. You can plug in anything. Because let's say if you have cube root of -8, that's not undefined. Alright? That's a defined result because it will give you -2. Alright? So the only thing that you will use this, or the only time that you will use this method for square root, in this case, is if the index is even. Just like here, it's square root of x squared plus 3x minus 28. Now, what are we going to do with that? So all we're going to do is set what's inside, so the inside function, minus 28, greater than or equal to 0. Now, why is greater than or equal to 0? Since square root of a negative numbers, or if we have square root of -1, that's undefined, right? So all we need is the numbers that greater than the negative numbers. Or if we plug in 0 under the square root, is it defined or not? Yes, it is defined. So square root of 0 will give us 0. So it is included in our domain. That's why we care about the numbers greater than and or equal to 0. So that's it. And whenever we have this, we must be careful. Of course, we will get the factor first. So we have, what's the factors? It's x plus 7 and x minus 4. And that's greater than or equal to 0. So with this information, we can say x is equal to -7 by this here, equal to -7, and x is equal to 4. So we just change the signs. So just like that. And we must be careful because in the number line, we said from the previous, we said that the answer here are not included. So just not included. But now, if this is 0, 4, and then -7 here is included to our domain. So now, for the functions that are greater than, we just have to check the region. So at this region, so here, let's say, what are the numbers greater than 4? It could be 5, 6, 7, or anything greater than 4. We have to plug that into our function and see if we got positive. Because if we have a positive result, well, that is okay to plug in here, right? Square root of a positive number will give us a positive number. And as we check here, if we plug in a number greater than 4 and we got negative, then it is not part of our domain, alright? That's how we check it. So, if we plug in 5 here, we'll get positive number times 5 minus 4 is still a positive, so we get positive here. And now, let's try to plug in negative, or number lesser than 4 but greater than 0. So, we have 3, right? 3 plus 7 is positive, but 3 minus 4 is negative now. So, this region here is negative. The sign is negative on that region. So, now let's try between -7 and 0. So, we have -8. So, if we have -8 plus 7, it's negative, right? -8 minus 4 is still negative. And if we multiply two negative numbers, so negative times negative will give us positive. So here, this region is included to our domain, and also here, but not this region. So now our domain would be, how do we write that in interval notation? So the domain is here, it's negative infinity, right? So from negative infinity to -7, since this is now the catch, since -7 is included, unlike from the previous example, this here, 4 is not included, so we write parenthesis. But now, since -7 is included, we write bracket, right? -7. And then, the union of from -7, this one, towards 0. So 0 is included, right? So 0. And then, what? Since this region here is not included, so we will not write that anymore. So since 4 is included, we write bracket. So from 4 towards, what's the region here? It's positive infinity. So parenthesis, because infinity is not a defined or a finite point. So this is now our domain for this particular example. Now, the fourth case, is if we have a square root on denominator. So square root on denominator. Denom. So which case is this? 1, 2, 3, our fourth case. So our example is, if we encounter this one, f of x is equal to 2x minus 7 over square root of x plus 3. So now what? How do we find the domain of this function? Let's start with, we know that the inside, since this is square root, even, inside of it, or the radicand, cannot be equal to a negative number, right? So we set this quickly, immediately greater than or equal to 0. That's our first step. Second is, the denominator of a function cannot be equal to 0, alright? Thus, we will just remove this equal sign, alright? You got it? Denominator should not be equal to 0, because if the denominator, if this inside function happens to be equal to 0, the square root of 0 is still 0, right? Therefore, this is what are we going to set for the inside. So the inside cannot be negative and also cannot be 0. That's why here, only greater than 0 is included. So with that, we can say our x should be greater than negative 3. Alright? So now that is our, this is now our domain. So let's start with 0. Let's start with negative 3. So this is negative 3, right? And now what? Is negative 3 included or not? Since it has no equal here, equal sign, it is not said that x should be greater than or equal to negative 3. Therefore, negative 3 is not included. So we write it as, so this is negative infinity here. So from negative infinity to negative 3, but not including negative 3. And then, is there any other points here? There's none. So the union of from negative 3, so I use parenthesis because negative 3 is not included, towards positive infinity. So this is now the domain of this function. Alright? Again, another example so you can see it. But this time, an example about here. What if we have f of x is equal to square root of x minus 4. So, over x squared minus 25. So, this is actually the fifth case, I guess. 1, 2, 3, 4. So, the fifth case, square root on numerator. So, the fifth case is square root on numerator. So, now what? What if we have this case here? F of x equal to root x minus 4 over x squared minus 25. So, again, denominator cannot be equal to 0. So, set that not equal to 0. And for numerator, since numerator cannot be equal to a negative number, just set that as x minus 4 greater than or equal to 0. Since we can have 0 numerator here and that's defined. So if we have this, so it will give us x is not equal to positive negative 5. Alright? Because if we transfer it, it will become positive 25 and the square root of that is positive and negative. Then here, x is just greater than or equal to 4. So now let's draw number line so you can see it. This is 0. And then this is negative 5 and then positive 5. Alright? And then what? Greater than or equal to 4. So 4 here, no. That's not the right place. So here we have 4. Right? So 4 is included since it's greater than or equal to 4. But this negative 5 and 5 isn't included to domain since it's not equal. So our domain here is from negative infinity to negative 5 but not including 5. And then the union of from negative 5, still not including 5, to positive 4, of course including 4. And then the union of including 4 but not including 5. And then from this one, 5, not including 5, towards positive infinity. Alright? This is the domain of this function. And the last one for this video, the example. What if we have square root on square root on numerator and denominator. So this time we have f of x over is equal to square root of x plus 3 over x squared minus 16. Square root of x squared minus 16. Again, denominator cannot be equal to 0. So x squared minus 16 cannot be equal to 0. And also cannot be equal to a negative number. So x should be, or this should be greater than 0. And for the numerator, there's only one exception, which is it should not be equal to negative numbers. So this is here. By that, we can say x could be greater than or equal to negative 3. And in here, x should only be greater than positive and negative 4. Again, we draw the number line. 0. So our point of concern is at negative 3. And then at negative 4, the iPod. And then positive 4. So from negative infinity, that's our domain. Is 4 included? No, because its x should only be greater than 4. So we don't actually write negative infinity here because all numbers less than 4 is not part of the domains. Alright, so we don't need to write that. So we begin with from negative 4, but not including 4, since here it's only greater than. And then what? Negative 3. So it should only be greater than or equal to negative 3. So we include negative 3. Then the union of from negative 3, including negative 3, to 4. Is 4 included? It should only be greater than 4. So we don't care on this region. Alright? Because if it is less than 4, here, the limit is negative 3. So it is not included. So we start with the union of, or not including 4, to infinity. So that's how you find the domain of these 5 cases. Again, all you have to remember is if you have a numerator that is under a square root or an even index, you should set that not equal to negative numbers, or in other words, you equate it to greater than or equal to 0. And if the denominator, you have a fraction and the denominator should not be equal to 0, so you set the denominator not equal to 0. And if the denominator is the square root of a function, then equate the function into greater than 0. Not greater than or equal to 0, huh? It should only be greater than 0. Because your concern are those greater than and not those less than and equal to 0. Alright? That's it for this video, guys. That's what domain is, how to find domain. And I hope you got something here. Thanks for watching. Peace out.